Hello developers, let's continue developing. My name is Veko and I will be continuing my solution of task number 14 of Advent of Code 2021. So, in the first part we need to do some kind of a polymerization, which basically from a string of four, let's call them bases, creates a string of much more bases. And we have certain rules when we replace basically each of these pairs of bases with we inject this base into the middle of these bases. So if we have n and cb, we inject a c between an n and the n, we inject a b between the n and the c, and when we inject an h between a c and the b. And of course, then in the next thing, we have the NC when we need to inject a B, we have the CN when we inject something else, and so on and so forth. So effectively, we're doubling the size on each turn. And since there are basically a limited number of rules and a limited number of combinations that we have, each substitution, each step increases the length almost by a 2. So if we're starting with 4 and the next increases it by 3 to 7, and then we have this 7 and they are increased plus 6 to 13, and then we have 12 more to 25, and then we have 24 more to 49, and so on and so forth. So basically in 20 steps we get about a million or so, and for the first part we just needed to run 10 steps. 10 steps we are increasing it to, actually I have no idea to how long we're increasing it, but let's find out. Yes, I want to do that. After step that one, what is the length of the polymer in the first part? The second part we don't have anything. So after the 10th step, the step number 9, the length of the string is 14,000 characters. And we need to find out some frequency, the most frequent and the least frequent character, and basically subtract their frequencies. That's all we need to do. But now I will just copy everything and paste this into a part 2. We're not gonna mess around with our part 1, that's done. But let's say what happens if I say, well, run up to 40. I'm quite confident that we will run out of memory somewhere. But most likely we will also run out of time. Step 20. And you can see that the time needed for each additional step, oh yeah, here we are. Paused before out of memory exception. Yeah, so we could have solved this if we needed to do the 20th step, but for the 40th step I think we need more memory to store our string than the Googleplex has. So unless we can pay a few $1 billion to rent out some of Amazon's data centers for our exclusive use, I guess we will need to solve this thing differently. So, what is the issue? The issue is here in our execute step function. And I will copy this over so that we can have a separate the solution works for part 1. So I will try not to break that. Execute step 2, and we have a polymer and we have the input rules. And from what I've been able to deduce is that on one hand we have a relatively limited number of possible pairs. So I want to represent this as an alternative representation. So I want to represent, and it kind of doesn't matter what the order is, because each time we are changing this with something else. So I want to display this as a collection like this, because this will fully explain it. I can say that I have one set of NN and one set of NC and one set of CB. And this fully explains what the content of the thing is. So I don't care how they are connected, I care only what they have inside. I don't think that I should be, actually I might be able to reconstruct this from this input, but from the counting perspective, these aren't identical. So I can guess what the step 2 will be. So for step 2, we need to get this, and we have these rules. So NN goes to, let's do this in 2 steps. So we have NN, and NN goes to NCN. We have NC, and NC goes to NBC. We have CB, and CB goes to CHB. So, and now we just split these off. So we have one CN, one NC, and I think all of these are different. Yes, we have one NB, one BC, one CH, one HB. This is a 1, this is a 1. So now we can again calculate the next step for these. So we have NC, and NC moves to NBC. We have CN, and CN moves to CCN. We have NB, NB moves to NBB. We have BC, and BC moves to BBC. Lot of network names, I guess. We have CH, and this moves to CBH, and we have HB, HCB. No HBO. So BC, CC, CN, NB, BB, BB, BC, CB, BH, HC, CB. And now we can just say, well, we have 2 NBs. We have a single BC. No, we have 2 of them. We have a single CC. We have a single CN. We have 2 BBs. We have 2 CBs. 1 BH, 1 HC. And we don't need this. Let's check if our process runs along smoothly. So we have NB, that's a 1 NB. We have BC, we have CC, we have CN, we have NB, we have BB, we have another BB. Yeah, that's right. And BBB. we have BC, we have CB, we have BH, we have HC, and we have CB. So we have two NBs, that part is correct. We need to have two BCs, that part is correct. We have a single CC, a single CN, two BBs, yep. A single, no, two CBs actually, that's correct. A single BH and a single HC. So it seems that our logic is effective. So we should be able to move from one step to the next just by adding something and increasing some numbers. And I will actually take this for a spin. So first of all, what I want to do is I want to implement part 1 using this logic. But I will just implement it in part 2, in the method called part 2. And so I want to make sure that for 10 inputs and for this set of data, because I already have an implementation for this set of data, for these requirements, that puts out something correct. And if it works, then I can just replace it. So first one thing we need to do is basically construct this. We need to transfer the polymer to a hash. So the polymer, our polymer, won't be the input string. Instead, it will be something, it will be a hash of numbers, because the key is a string and the value is a number. And we can just initialize it to an empty hash. And then basically, if we have a 4-letter string, we have 3 items. So we will not need to run this until the input.polymer.length -1. And that's not the element we need. So we will need to get the key, and the key is, well, this substring where we're taking from the index up to and not including 2 more than the index, so we will get 2 characters. When we are getting 2 characters, that means that we can, do this. We can add this, increase the count of the polymer. Let's see how this polymer looks actually. Comment this out for the time being, return 0, so TypeScript is happy, this is not really used, and let's just run this. We should get something very similar to what we described, and indeed we are. We're getting the exact that, NN, NC, CB, each of them one time. So now the next thing that we need to do is to implement this. Polymer is execute step 2 of polymer. So this won't take a string, it will take a hash of number. Which means, whatever we were doing here, we did it. Now we already did it before this. So instead of having insertions, I think nothing from this is salvageable. And if it is, I still have the original execute step method. Nope, not at all. Actually, I will generate another value that will be called result. And now, for each of the items, I need to loop because I don't need to loop through the values. I need to loop through the keys of this. Would it have been better if I had not a hash but an array of tuples, because I kinda don't need the lookup, I need to loop through them. On the other hand, it's easier to set it. Well, what I'm talking about is that maybe I can use a structure like this, which is a string number tuple array. Something like this. Now this will be much easier to loop through. But on the other hand, I don't think that I will need to loop through it a lot. But I do need to loop through it right here. So that's my least favorite for loop, and that's the for in loop. Since we don't need this, because we're not using complicated objects, we know exactly what's in the polymer thing. Because in the polymer things can be only things that we put here. We don't have any kind of whatever, any kind of inheritance or prototyping or so this is not a key, this is a base. No, it's not a base, it's basically a base pair. Let's call it a key. Let's call it a base pair. And this is the value of the base pair, is polymer of base pair. And what we now need to do is, we need the rules as well. Yep, we need this. The target base is what we're gonna use to actually add it to the new polymer, to the result polymer. So what we're gonna do is we can just say const base 1. That's, well, since we know it's a 2-letter string, we can just do this, and I guess, Copilot guessed that one. And then what we can do, what we should do, is basically calculate the results. So we have this right now. We have the text nc, and we have the value n and the value c, and also we have the value b. And we need to take the first one, we need to take the n and the b and generate one, and take the b and the c and generate another. Or in code, not this at all. Base 1 is not base pair 0, but this is plus target. Because each base pair will generate 2 items. And then we add that. And now we can do a result of base 1. Yep. Add the value to the base 1 value and add the value to the base 2 value. And that's all that we need. It is a bit convoluted, but sounds about right. And we're returning, yes, it knows it's returning a hash of numbers, so we can assign it to the polymer, and we don't have a length thing, but let's just print out the whole polymer, and I will put it to run just once. And this will complain that we are not returning anything, just return 0. This will run once, and if we are correct, I was going to say that we need to see basically this, but because we kind of put it into a extrapolated string, what we got was a object. Console log is very smart, and it will correctly log an object, but not if you force that object to become a string. And we did just that, so we got object. So we got this. 1 NC, 1 CN, 1 NB, 1 BC, 1 CH, 1 HB. I even got the ordering right. That's great. And if we run it twice, and I'm running it slow. We might get a correct solution if we put it at 40 immediately, but I have no way to check that I'm correct. We have 2 NBs, 2 BCs. Yeah, the algorithm is straightforward, so I think that we should get the exact same order as well. 1 CC, 1 CN, 2 BBs, 2 CBs, 2 BBs, 2 CBs, 1 BH, 1 HC. Yep. So now I'm gonna let it run until 10 and just comment this out. And that was a bit on the stupid side, because we kinda need this. We need some kind of output. Let's see, yeah, we got something that I'm gonna need a lot of Excel to see if it actually makes any sense. So yeah, this is the situation that we're having. Let's see. Well, let's do some Excel. This strips the formatting, so we can paste it easier in Excel. So each of these pairs are appearing this many times. And this actually means that, let's do this, and this is the leftmost part of the string, and this is the rightmost part of the string. Yeah, and run the gamut, and you as well. So this means that we have this many n's. Yeah, that's not gonna paste nice, but I don't really need the n. This is, let's have it like this. This is the n's, this is the b's, this is the c's, and this is the h's. I think those are all that we have. And I will remove them as I paste. So this is a B, this is a B. Oh, if you cut it, it works. This is a B, this is yet again a B, this is an N. Are you sure we have other letters? Yeah, this is a B, this is 2 C's, and 2 more C's, and an N, and another N, and a C, and a B, and an H finally, and a C, and an H, and an N, 2 H's more, and we're done with this column with a B. So some more copying and pasting. B, H, H, H. Well, that's cool. And then we have an N and a C and an H. So now we should get the count of each of the letters. Okay, we have 322 H's and we were supposed to get yeah, 161 H's, which is exactly the half of this number because we counted each H twice. We counted it as a part of the first base pair when the H is the last letter of the base pair, the second letter of the base pair, and we counted it once when it was the first letter of the base pair. And I would say that we are counting each and every letter twice except the first one and the last one. So the first one and the last one will be the only ones that get counted once because they are not part of two bases, they're part just of one base, and everything else is counted twice. So yeah, even if you take a look at these, let's have the sums here. So we can look at them together. You can see that we have two even numbers and two odd numbers, because these two odd numbers are basically one of the first and the last letter, and I don't think the first and the last letter changes any time because we're just inserting starting at the every position, at the between position. So the first one will always be an N, the last one will always be a B. And if we analyze these, I would say that O and F will have an odd count and everything else will have an even count. But I'm not gonna do that because this part is kind of boring. So if I want to get the correct values, I will need to say, well, this divided by 2, yep, and yep, and yep. And does Excel have a, what do I need? Do I need a floor or a ceiling? We actually need the ceiling because we need to count the number we are counting once, we need to count that. So yeah, that one, I guess. And I think that I'm correct, but let's see. How many N's do we need? 865, 865. B's, 1749, 1749. C's, 298, 298. And H's were already known to be 161. So yeah, this thing produces results. So now we need to crunch this in the same way as we did it here. So we will need to calculate the histogram basically. We have the correct polymer, we need to calculate the histogram, and we're gonna need another Fourier cycle. Base pair in polymer. Well, it says maybe you want to do the same thing that you did before. No, I want to do something else. I will take the first one to be this and the second one to be that, and then yes, this one is correct. I will add to the histogram of the first the value of whatever was here. So this was the part when I split them in two and I pasted it over, grouping them. So this is for the first one, and of course we need to do the exact same thing for the second one, and we're done. So let's just say console log histogram to verify that we get the correct values, and if we are correct we should get these numbers, or we should get a compile error because we don't have a return 0 at the end. $17.29, $34.97, $5.96, $3.22, and now I'm gonna need a third for-in cycle. As soon as I spoke that this is my least favorite for loop, I had to do like 3 of them. So I will just do histogram of key is equals to math dot ceiling of histogram dot key divided by 2. Yeah. We could have done an object entries or object keys map or something like that, but I think this is the one that kind of looks best, even if it is a for-in loop. And knowing what I wrote for part 1, I think that our histogram right now looks just as correct as this. But, you know what? We're not using the zeroth element anywhere, so we don't care what the histogram's value is. Yeah, we don't need object entries, we need object values. And object values returns, in this case, a number array. So we know that B is a number and A is a number, so we can omit that. And of course, we have to with this because JavaScript is JavaScript. One thing that annoys me all the time is because somebody thought that this would be fine. If we have 1 to 10, the array 1 to 10, and we say we want to sort it, yeah, this is the way we got it sorted, because 10 is less than 2. I have no idea how or why, but this is how it works. If you want your numbers, okay, let's have it the other way around actually, so it's actually doing something. If you want to actually sort numbers, you have to always do this a comma b arrow b minus a minus b, and now it sorts itself correctly. And this was very much more fun to write when you didn't have arrow functions, so you had to do something like function ab return. Yeah, this looked so much better, and you got to debug where the missing thing was. So yes, because we want to sort numbers, we have to specify we want to sort numbers. And then we don't need this and this. And if I am correct, we should get the exact same value as we did before. 1588, 1588. We don't need the console log anymore. And let's try this same thing on the largest input. and you can see we have exactly 100 rules. $25.90, so I am kind of convinced that this thing works. Actually, I'm so convinced. Let's just view the terminal one more time. Which one of these was faster? Well, definitely the second one. So now empowered by GitHub, because I cannot lose my code. This is already committed. Even if I make some great blunder, then nothing is lost. I will just revert it. So I will take this code and use this for part 1 as well. And actually, yeah, let's paste it first, and it says execute step. Since we have this, let's parameterize this, and then we can do this. Yep. Diff. Yep. This is a function that will get put at the end. I will just put it a bit before because I want the export const thing to be at the end. So I will define it somewhere around here, and this is just a preference, but I kind of prefer everything that can be a lambda to be a lambda or an arrow function. Yeah, so now we only have that code once, and this means that the only thing that we need to do for part 2 should be this. But still, I'm gonna run it on the demo first, and let's see if the demo returns the correct value. Well, it's a large number. And if it's the correct large number, I would be somewhat not surprised but emboldened that we have the correct large number for the demo case. So now we just need to say, show me the real input and run me the real input. And the real input provides us with a different large number. And here's hoping that the different large number is not off by 1. That's the right answer. We have one more gold star, 28 total, and our advent calendar is starting to look cool. So, thank you for coming this far. Don't forget to like and subscribe and whatever people say at the end of Facebook, of YouTube videos. And that should be it. Talk to you tomorrow.